Hello friends, hope you're all doing well. Today we are going to discuss on the topic of nuclear reactors. I am Amarnath. Let's get into the video. The basic idea on the nuclear fission was the splitting of unstable atomic nuclei, consider uranium 235, by colliding it with slow neutrons, which was also unstable, splits the nucleus with the releasing of daughter neutrons. The daughter neutrons is responsible for the further chain reactions in the nuclear reactors. This process is induced in the nuclear reactors, but naturally there are no neutrons need to induce such a reaction because the mass number of the unstable nuclei was very high, which was responsible for its radioactivity. On contrary, the colliding of the two atomic nuclei is known as the nuclear fusion. The similarity between the fission and the fusion was the releasing of energy in the form of radiation. The following reaction in the video explains the fusion of the two helium-3 atoms to form the helium-4 with the releasing of two hydrogen atoms. The nuclear fission reactor, where the nuclear fission takes place. The nuclear fission reactor comprises of the fuel rods, where the fuel is physically located in the form of pure metal or in the form of ceramic. The shielding was done outside the reactor core to prevent the radiation leakage. Generally, the shielding was done with the concrete of about 7 to 8 feet. The coolant pipes, where the moderator liquid was circulated between the heat exchanger and the reactor core. The control rods or control materials. To control the continuous chain reaction in the nuclear fission reactors, the control rods are employed. In thermal reactors, control is achieved by means of a neutron absorbing materials. The material should not become radioactive as a result of neutron capture. Elements with relatively high thermal neutron absorption, such as cadmium, boron, hafnium, iridium, mercury, and mixtures of the rare earths, are used in the form of rod in the nuclear fission reactors. The coolants are the materials which was used to remove the heat from the reactor core. They do not break up under irradiation and they should not react chemically with the other materials when it contacts with the system. At ordinary temperatures, the light water and the heavy water may be used as the coolant, but at higher temperatures, the liquid metals such as sodium are used as the coolant. The coolant towers in the nuclear power plants are used to extract heat from the water and releases it into the atmosphere. Now let us move on to the classification of nuclear reactors. In homogeneous reactor, the fuel was mixed with the moderator in the form of solution. But in the heterogeneous type, the fuel was in the form of capsules or rods. Reactors are classified into three types according to their purpose. They are research reactors, production reactors, and power reactors. The energy produced in the research reactors are comparatively small. They are only used for the neutron supply and for the radioisotope production for research purposes. The first type of research reactor was the graphite moderator reactor, in which the graphite is used as the moderator as well as reflector. It is of heterogeneous type. The next type of research reactor is the water boiler type. It is a homogeneous type reactor in which the enriched uranium is mixed with the ordinary water in the form of solution. The name is often confused with the boiling water type reactor. The name is due to the sudden increase in the power will cause the formation of steam bubbles in the solution. The next type of research reactor is the swimming pool reactor. It is a type of heterogeneous reactor which consists of a lattice of enriched uranium fuel immersed in a large pool of water. That's why the name. The water in the pool plays the role of moderator, coolant as well as shield. The next type of research reactor was the light water moderator reactor or tank type reactor. This reactor has the same principle with the swimming pool reactor. The core is suspended in a deep cylindrical tank of water and the light water is used as the moderator. This reactor has the large number of holes for the neutron beams to enter and the increased of neutron flux was designed and built in 1952. This reactor was also called as material testing reactor. The reactor of next type uses the natural uranium as the fuel, heavy water as the moderator, helium as the cover gas and graphite as a reflector. This reactor core was cooled by circulating the demineralized light water in a closed loop. The next type of nuclear reactor was the production reactors. This reactor has the main function of converting the fertile material into fissile material. For example, the uranium 238 is converted into fissible plutonium 239. The next type of nuclear reactor was the power reactor. The purpose of this reactor is to convert the fission energy into useful electric energy by means of heating the core. The heat is directly or indirectly used to heat the steam or gas. The steam or gas runs the turbines to generate the electricity using the generator. Pressurized water reactor is a type of power reactor. It uses slightly enriched uranium as the fuel. It is of heterogeneous type. The core of this reactor is maintained at high pressure to prevent the boiling of the coolant. As per law of thermodynamics, heat is converted into useful energy when it is released at high temperatures. The high pressure gives us the name pressurized water reactor. The next type of power reactor was the boiling water reactor. This reactor uses light water as the coolant as well as moderator. This reactor has the simple design and more advantageous than pressurized water reactor. This reactor does not require more pressure as that of pressurized water reactor. This reactor generates steam directly into the core to run the turbines and generate electricity. The steam is converted into the water again using the condenser and feeded it into the core, so it doesn't need any heat exchangers. Other types of power reactors include heavy water moderator reactor, in which the heavy water is used as the moderator. Organic moderator reactor uses organic liquid with high hydrogen content as the coolant. The gas-cooled reactor uses gases like helium or carbon dioxide with nitrogen is used as the coolant. Sodium graphite reactor uses liquid sodium as the coolant. Liquid fueled reactor uses liquid uranium sulfate mixed with the light or heavy water as the homogeneous mixture is used as the fuel. And the fast breeder reactor uses fast neutrons to produce more fissionable products, which is responsible for bulky nuclear reactions. These are some basic information on nuclear reactors. Hope you will find this video useful. Connect with us for more information. Thank you.